and welcome. In this video, we are going to see favorite number question. Okay, we will see what is the problem statement, understand the problem statement, then build a logic and then implement that logic. Okay, let's see how to approach this one. So favorite number. Among all the digits from 0 to 9, everybody likes number 5. So his favorite number is 5. Okay. He has lots of numbers and wants you to find out the number of times 5 occurred in a number. Okay, number of times 5 is occurring, a digit 5 is occurring in a number. Okay, that we have to find out. Okay, so the first line contains a t, that is denoting the number of test cases, and each t will contain a single integer n. Okay, for each test case we have to print how many times a 5 is occurring in that particular number on a new line. These are the constraints, these are the time limit, and this is the example. Okay, so let's see the example. So t value is nothing but 3. That means we will have 3 test cases. In the first one, n equals to 1, 2, 3, 4, 5. So in this, how many times 5 is occurring? 5 is occurring just one time. Therefore, for this one, the answer is nothing but 1. In the next one, n equals to 3, 4, 5, 6, 5, 4. In this one, how many times 5 is occurring? So it is 1 and 2. It is nothing but 2 times. So the answer is 2. And in the third one, n equals to 5, 5, 5, 5 and 5. In this time, how many times 5 is occurring? It is 1, 2, 3, 4 and 5. So the answer is 5. Okay, so the question asks us, given a number, okay, you have to find out how many times a 5 is occurring in that number. How many times digit 5 is occurring in that number. That is the whole question. Fine. So let's begin with the logic building part. So here, let's see the second example, 3, 4, 5, 6, 5 and 4. In this one, the 5 are present in the middle, that is this and this, correct? So how do we access these 5s? How do we access each digit of a number? That is a question that we have to answer. How do we access each digit of a number? How do we access this digit, then this one, then this one? That we have to do. Once we can access each digit, then we can check whether that digit is equal to 5 or not. If yes, we will increment the count. That part is simple. But now, before that, what we need to do? We need to find out how we can access each digit. Okay, let's see that point now. Now, how can you access the last digit of a number? You might have done this. How can you access the last digit of a number? So the last digit of a number can be accessed by simply modulus 10. By doing modulus 10, what is the meaning of modulus 10? 3, 4, 5, 6, 5, 4 divided by 10 will give us a remainder as 4. Okay, so divide by 10 will give us the remainder, which is nothing but the last digit of a number, okay, so when we do mod 10 of any number, it will return us the last digit of that number. Okay, whatever the last digit is. So we got the last digit. Okay, now how can we get the second last digit, or the third last digit, or the fourth last digit? How can we guess these? So getting the last digit is a simple part. Okay, whatever n is, just do mod 10 and you get the last digit. Okay, so what if we can make all these digits one by one the last digits of a number? What if the first one is this, then it should become this, then it should become this, then this, then this, and the final this. So now this number has a last digit of 4. Okay, the second number has last digit of 5, then the third number has last digit 6, last digit 5, 4. So now these can be easily done by mod 10. This can be easily done by mod 10, correct? So how do we actually get these numbers? Now this is the question. How do we actually get these numbers? That is, how do we make 5 as the last digit? How do we make 6 as the last digit? For that purpose, we will be using divide operator. Okay, how to use that divide operator? See, given a number, for example 1, 2 and 3. If I divide it by 10, what is the answer? It is nothing but 112.3. But this is also an integer. Integer cannot contain after decimal digits values, so it will convert this into 12. Okay, the compiler will convert this into 12 because we have integer division, so the answer should also be in integer, so 12 will come as the answer. Okay, now if I have 1, 4, 5, 6 and I divide it by 10, so actually it is 145.6, but this will not be there, this will be truncated because we have to convert it into integer, so the answer will be 145. So as you can see in both these examples, when we divide by 10, okay, the last digit is removed. Last digit is removed when we divide by 10. Okay, by doing modulus, last digit is not removed. Okay, but by dividing by 10, the last digit is removed. Okay, so 145 divided by 10 will give me 14. Now 14 divided by 10 will give me 1. Now 1 divided by 10 will give me 0. So here we have to stop. Here we have to stop. As you can see, from 145 we go to 14, then we go to 1. Okay, so using the divide operator and the modulus operator, we will solve this particular question. So I think you have understood how do we get the last digit of a number and how to divide, what is the use of division here. Okay, and then after we get from 3 this big number, we get 3 4 5 6 5, then again we will use mod 10 on that to get this last digit and compare it. Then again we will divide by 10, we will get this number and we will compare the last digit. Then again we will divide by 10, we will get this number and we will again get the last digit. Okay, so I hope you understood the use of division and modulus in these particular type of problems. These are very important problems. Okay, getting the first digit of a number, getting the last digit of a number, okay, getting any particular digit. So to access each and every digit, we will use modulus operator and division operator. Okay, let's begin now. We have everything that we need. Okay, we know we have to use both these operators. We know that this will give me the last digit and this will remove the last digit. Okay, so let's now do it. Okay, so let's see. N equals to 5 4 5 4 and 5. Okay, so get the last digit. How? So for example, remainder equals to 5 4 5 4 5 mod 10. This will give you answer as 5. Remainder equals to 5. Now we need to divide this number. Okay, so we need to do this. N equals to n by 10. So what will happen? N value is nothing but 5 4 5 4 5. Divide by 10. What it will become? 5 4 5 4. Okay, I have explained you this, that 5 4 5 4 5 divided by 10 will give me nothing but 5 4 5 4. 0.5 will be truncated out. Okay, now repeat this step. Repeat this step. Okay, here n will come. Repeat this step. Now n value is nothing but 5 4 5 4. So the last digit we get is 4. Then again divide by 10. So we will get 5 4 5. Then again repeat this. So last digit is nothing but now 5. So this will be repeated inside a loop till the n becomes equal to 0. When n becomes 0, the loop will break. Okay, till n is not equal to 0, the loop will continue. Till n is not equal to 0, the loop will continue. Okay, so this is how we are going to access each and every digit. So now after accessing each and every digit, now it's become quite simple. Whenever you get a remainder, you just need to check whether that remainder equal to 5 or not. If it is equal to 5, then we have to increment the count. If it is not equal to 5, we have to do nothing and the loop will again start. Okay, so let's now see the implementation of this. Okay, so what we are going to do, it's very simple. Given a number n, we'll access the last digit, we will divide it by 10 and we will repeat. Okay, and in the middle we will just compare with digit 5 and we are done. We are done. So let's see the implementation part now. So first we will have nothing but an input of t. Okay, second we will have a loop for the test cases. Third, we will have input n. Fine, let's declare a variable remainder. Okay, then after this we will have a loop. Okay, that will be running till n is not equal to 0. When n becomes exactly equal to 0, the loop will break. Fine, now inside of this we will have remainder, which is nothing but our n mod 10. Okay, we will check if this remainder equal to 5. Is it equal to 5? We will increment the count. So that means we will need a count variable as well. That means we will need a count variable as well. So here we will declare a count variable also. Okay, then we have to just do n equals to n by 10. Now this is going to loop. This is going to repeat till n becomes not equal to 0. How that will happen? 456 will become 45. 45 will become 4 and 4 will become 0. Divide by 10 each time. Okay, so when n becomes 0, the loop will break and we will print our count. So this is the implementation. Okay, this is a normal direct implementation, that we need these variables. We know what variables we need, where to declare them, where to initialize them, and how to write the code. Now let's see in the code. I will just implement exactly these points. So this is important, guys. Okay, you have to always write these steps before you write the code. This helps you to know how many variables you need inside your code. Okay, and where to use those particular variables. So before moving to the implementation, let's just run it out. Okay, so for example, n value is 3 4 5 4 5. How this code will going to run? So remainder is currently 0, count is currently 0. Now a loop will run, loop till n is not equal to 0. N value is currently 3, 4, 5, 4, 5. So first remainder will be n is 3, 4, 5, 4, 5 mod 10. So the answer will come as 5. Remainder equals to 5. Now this condition will be checked. Is remainder equal to 5? This condition will be checked. Yes. So count will be incremented to 1. Count will be incremented to 1 and n will become n by 10. So what was n? 3, 4, 5, 4, 5. So now what n will become? 3, 4, 5, 4. Okay. Then again we will loop back. Okay. Now for 3, 4, 5, 4, this statement, the first statement, this one will be executed. Okay. Now when this statement is executed for 3, 4, 5, 4, the remainder is nothing but 4. That is the last digit of a number. Is this equal to 5? The second statement is executed. Is this equal to 5? No. So the count will not be updated. Okay. Then we will go to the third statement from here to here only. We go to the third statement and n will become now 3, 4, 5. Okay. Because n by 10 will give me this as the answer. Now again we will loop back. Is n not equal to 0? Yes. N is not equal to 0. So we will come inside. Now what will be the remainder? Remainder will become 5 again. Remainder will become 5 again. Correct? And mod 10 will give me 5. So second line, if remainder equal to 5, count plus plus. So count value will now become 2. Fine. Then the third line, n equals to n by 10 will give me 34. We loop back. Remainder is nothing but 4. Is 4 equal to 5? No. No increment of count. So n equals to n by 10. We will come to 3. Is 3 remainder 10 is nothing but just 3. Is 3 equal to 5? No. No increment of count. N value will become 0. As soon as n becomes 0, this condition will become false. We will break from the loop and we will print the value of the count, which is nothing but 2. So in this case, the count value was 2. So this was whole the dry run of the algorithm that we just wrote. And this is how this whole process is going to run. Fine. So now let's see the implementation. So let's implement the code now. So int t equals to sc.nextInt while t minus minus is greater than 0. So the loop will run for t number of times. Now int n equals to sc.nextInt, taking n as the input, then taking our two variables, remainder and count, which is equal to 0. After this, it's simple, just a loop that will run till n is not equal to 0. As soon as n becomes 0, it will break. Okay. Now after this, what we have to do? So after this, remainder equals to n mod 10. So this will give me the last digit. N equals to n divided by 10. This will give me, this will just remove the last digit. And if remainder equal to 5, then count plus plus. Okay. If the remainder equal to 5, then count plus plus and just print the count. Okay. So let's just test this code out. Okay. So we will take some 5 to 6 test cases and we will test the code. If it is running for those test cases, then we are going to submit it. Fine. So let's test for 5 test cases. So what if all are 5s? So yes, the answer is coming as correct. Single 5. Yes. No 5. Yes, 0 is the answer. 1, 2, 3, 4, 5. Yes, 1 is the answer. 5, 4, 3, 2, 1. Yes, 1 is the answer. So let's try and submit it and see if it is correct or not. Okay. Just copy it and let's see if it is correct or not. So when I copy paste the same solution and selected Java as a language, submit the code and it will be accepted. So this was favorite number question. Thank you.